Welcome to the Post-Tension Parking Structures webinar series, proudly presented by the Post-Tensioning Institute. This series is dedicated to showcasing the advantages and benefits of post-tension parking structures. This four-part series, moderated by PTI's Executive Vice President Tim Crystal, brings together a panel of industry leaders, including Asit Boxy, Michael Pedraza, Tom Pfeiffer, and David Wolkin. Throughout this series, we will deliver practical insights and technical knowledge to empower industry professionals in choosing post-tension concrete as the preferred option for parking structures. Covered topics include functional advantages and benefits, cost-effective design and construction features, sustainability and resilience advantages, and long-term durability case studies. By joining us, you gain access to thought leadership and a comprehensive understanding of how post-tensioning can enhance parking structure design and performance. Let's join in on the conversation.
All right, so welcome everybody to our fourth episode in this series of webinars discussing post-tension parking structures. This fourth episode ties together with all of our other episodes. We've had an episode on the functional benefits of PT parking structures. Cost effectiveness, of course, is part of that as well. We've talked about the sustainability and durability and sustainability and resilience of post-tension parking structures. Obviously, lots of different things about structural benefits and things of that nature. And today we're going to dive deep into the discussion about durability. This is certainly a key feature of post-tension parking structures. Long-term durability ties into a variety of important topics. Specifically, you think about life cycle costs for a structure. You know, the importance of first cost is certainly there when you're building a new parking structure, but it's equally important to think about long-term costs of maintenance and repair and things like that. So post-tension parking structures are superior when it comes to life cycle costs and how important that is. So again, we'll talk to our esteemed panel here, folks here, and have a discussion again about durability of post-tension parking structures and stack that on the other topics we've already talked about before. So let's go ahead and get into it, folks.
I can take the first stab. Just from a durability standpoint, as a contractor, I think we're front end, but I can say that pouring these slabs in a lot larger, more monolithic fashion definitely helps with the durability, whether it's water intrusion or, as we said before, it limits joints, so you don't have the corrosion of the joint fillers, things like that.
Yeah, I think there's a big advantage of having a pre-stressed parking structure, and the main advantage that we see as as a designer in the durability aspect of it is the fact that the pre-stress is putting pre-compression into the system, and that what that's doing is, it's doing a lot of things. But really what it does for durability is it keeps the concrete in compression as much as possible, and that's going to limit cracking and other issues there. So that's one of the main reasons why when I have a parking structure, I pretty much automatically go to a pre-stressed post-tension concrete structure for that. And we've seen time and time, there's plenty of examples that show over 30, 40 years that it just behaves, really good, and even longer than that. But at least in my lifetime, I've seen that. So it's definitely a good system for a parking structure, and it's something that I think is definitely top tier.
And I'd ask, I'm again from the construction side, but ask you, one of you guys from the design side. Do we see less thermal expansion, from a PT deck versus some of the others? Is some of that less movement, obviously is not as hard on connections? Is that a true statement?
The benefit of having post-tension when you're talking to volume change is that, these PT parking structures that are exposed to the environment are constantly moving day and night, all year long. And so the benefit of the pre-compression, we'll talk a lot about pre-compression, is that as the structures tend to move around due to the environment, the post-tensioning keeps everything together, to put it very generically. And to Tom's point, and I'm sure we'll discuss more, as everything, as the pre-compression keeps it together, as it wants to move around, there's less tendency for things to crack. And so you're inherently getting that as a benefit for your volume change movements, whether that's due to temperature, creep, shrinkage, all of that. You're always in a state of pre-compression if you've got the right design, right? To kind of add to that, we do specify when we think is the optimal time to apply that pre-stressing, and that can vary from designer to designer, but it is really important that you get in that pre-compression in as soon as you can. And the big benefit of that is, we talk about durability. We want to try to limit the infiltration of essentially chlorides into the slab, where it can get down and start doing damage to embedded items. And if you can get on it early enough before you start getting that initial cracking, you can either close up the tiny little cracks that start forming, or you could try to essentially almost keep it from happening. And if you can stop that initial crack from forming, you can essentially you're essentially keeping it from cracking any further. And so if we can eliminate the crack from the start, we're already off to a better start in terms of durability. So there's always like, well, how do we mitigate cracks that already form? Well, let's just try to keep them forming in the first place. And so we find that very beneficial. And we have seen examples where when the pre-stressing isn't done at the right time, you get a bunch of initial shrinkage cracks, and you can actually see the concrete starting to effloresce before they even open. And so it's really, really important to do it at just the right time. But if you do it, if you can execute it that way, it's a very durable system.
Yeah, I'm going to start by saying that the key to durability is keeping the permeability in the concrete very, very low, right? So that's your starting point. And you start with good materials, low water cement ratio, that kind of stuff. But the first step, simply by pre-stressing the concrete, you're helping in reducing the permeability of the concrete. So pre-compression levels in cast in place post-tension concrete structures are a key. And I'm talking about pre-compression in both directions, not only in the direction of bending, but also in the transverse direction, which is for shrinkage and temperature cracking. And typically as you all know, the pre-compression levels are a lot higher for cast in place parking structures, simply for improving the durability of the structure, right? So depending on the exposure of the structure, I think we have, is it 4 different levels of exposure? Your pre-compression levels can vary from 125 psi to up to 200 psi in both directions. And I think that helps a lot in keeping the structure tight and improves the overall performance of the concrete garage with time. So that's the pre-compression level. The other thing you can do during design is, depending on the demands of the structure, even depending on the owner and cost, you can control the permissible stresses in the deck. So the engineer has the option of going from uncracked, keeping the structure uncracked, all the way to acceptable level of cracking, so much higher level stresses. But by controlling the stresses in the decks, you have much improved deflections. I think you can come up with a garage design that is cost effective and durable. So that improves the serviceability of the decks.
One thing to mention about the post-tension system that we use in these parking structures is that they are an encapsulated system. So the benefit of that is, you're keeping water out of the system. You're protecting the steel within the tendon, protecting the anchors. And then inherently with the post-tension system, you have a sheathing and you have grease, and then you have the steel strand within that. So you're basically having a good protection system on that pre-stressed post-tension tendon, which is definitely a big benefit for the durability of that, because if there is any water that gets through the concrete, gets through any cracking, you're protecting that system. So that's one thing to mention on the pre-stressed post-tension tendon.
That is correct. I think if you go back to the history of encapsulated, the improvement in encapsulation, going back 40 years, you had the standard system, you had improvements in the encapsulated system, and now there have been tremendous improvement in the encapsulation of the tendon from end to end. So there's full protection, corrosion protection, right from the anchor to the fittings, all the way through the sheathing, and that provides tremendous protection for the tendon materials. That's something that I didn't talk about. So in addition to the concrete, it's also the encapsulated system, and this applies to unbonded tendon systems and even bonded tendon systems too. So although unbonded tendons are more primarily used in the US, but there are cases where you have bonded systems too, especially maybe for transfer girders and stuff like that. But post-tensioning provides a very high level of corrosion protection for the tendon, which greatly improves the durability of the parking structures. And we'll talk about tendon finishing and all that once we get into the construction side of the discussion. But on the material side, that is a tremendous advantage that we have by using post-tensioning in our decks.
You're also limiting the rebar as well. I mean, there's reduced amounts of rebar with PT. So when you talk about corrosion, somebody might say, well, there's still rebar in the deck and it's not protected, but there is less rebar in a PT slab. Your PT is your main, excuse me, your main reinforcing, and it's protected.
Yeah, that's a great point, Mike. We probably talked about this in other segments, but in typical structures, you can basically get your reinforcing down to minimum. That's minimum length, minimum size, maximum spacing, by using post-tension solution. And when you're doing that, you're cutting out a huge percentage of potential issue just by going with that. And we're talking about reducing mild steel by what, 50% or more. So it's really helpful.
One thing to talk about with respect to durability is the fact that with the post-tension parking structure, you have that monolithic structure. And let's talk a little bit about drainage. I mean, drainage is very important for durability. You're going to get water in an open deck, and so you want to be able to drain that. You want to be able to get rid of that as much as possible. And what a cast place and a post-tension parking structure allows you to do, it's a lot more flexible. You have less joints. You can warp the slab. You can create drainage a lot easier than some other types of structures. And you can make that water kind of go right towards the drain and get rid of it quickly. And the quicker you can do that, the better you're going to be with durability. I think we've all been in parking structures where you go out there and there's ponded water here and there. And that just really will decay the structure pretty quickly over time. So that's a benefit, I think, of a PT structure. You have the ability to really kind of morph that into what you want and work the drainage and have lack of joints.
That's a big thing, Tom, is jointing. When you think about traditional concrete, everybody say concrete cracks, right? I got, whether it's a wall or a slab or whatever, and the thought process is we have to control the cracking by providing joints everywhere to force the crack to form where we want it to, right? Well, with PT, you kind of have to think about it almost fundamentally differently. You don't need to, right? If the concrete's not going to crack, you don't have to provide a joint. And if you don't have to provide a joint, you don't provide an access for water to get in. And to your point, Tom, water's flowing across these floors all the time, trying to find its way to the lowest spot. It doesn't have to travel across 12 cracks to get to a drain, whether they're there, and the crack is going to form there if it's not post-tensioned, right? So you're either going to have to maintain some kind of joint filler, or you're going to have to maintain a joint that's not filled. So yeah, excellent application for that is that you're eliminating the requirement for joints in your slabs.
Yeah, absolutely true. In fact, if you really think about it, of all the available solutions out there, a cast-in-place post-tension deck probably offers the least amount of joints, right? You can even for very, very long parking structures, maybe you can have an expansion joint, but you're not going to have a construction joint or multiple joints. So that is absolutely the case. That the limiting factor would just be how much concrete a contractor can pour. If they can mobilize more personnel and pour a 18,000 or 20,000 square foot deck, or it depends. It can vary from 12 to 18,000 feet or whatever the case may be. But it definitely is the best option for having the least number of joints.
Thanks, Asit. I misspoke. I said you're eliminating joints. You're not. You're minimizing the number of joints that you could actually need in there.
Yeah, and I don't want to bypass the other thing Tom said, which was controlling ponding. I think PT with the ability to design around and for long-term deflections and things like that. I mean, you do reduce ponding, which you see in other structures that don't have those internal forces to offset it.
Yeah, you make a good point, Michael. I mean, just PT is going to help you with deflections, right? So, I mean, generally we have a lot less deflections in a PT structure than we would in just a regular mild reinforced structure. So having less deflections obviously is going to help with ponding and help with drainage. I mean, you can design drainage all you want, but if you have a lot of deflection with the drainage, it usually overcomes that positive drainage that the architect or whoever's trying to design on the front end. So you want to make sure that you're basically following that drainage system and you're not over deflecting the structure, and PT definitely helps with that significantly.
Thought I might interject a little something here on the you talked about materials and how important the encapsulated PT is. Obviously, the materials side is both the manufacturing of those materials and then the installation and stressing and all the workmanship side. So the other thing that's key, and it's also tied into the codes for a post-tension parking structure and elevated post-tension structures of any kind, is you've got PTI certified plants that are, making the post-tensioning. They're the PT suppliers, so they've got to follow a specific process tied into the PTI M10 specifications. So it's critically important that you're having the high quality materials through that process. And that's, again, through the codes and through the PTI certified plant program. That really is reinforcing high quality to start with on the materials side. And then the workmanship side comes through the field personnel certification workshops. So there's level 1 unbonded and level 1 and 2 unbonded PT workshops that are all tied into being able to get your field personnel certified by Post-Tension Institute, the general crew, the people that are working on the installation and process, the foremen, the superintendents, the people that are involved in that whole effort. And that it really initiates and puts forth high quality workmanship. So you're now installing these materials correctly, you're stressing them correctly, you're finishing them correctly, and anytime all of those things are met, as far as the materials running through their course all the way through the final state, that improves long-term durability, of course. So that's a huge thing to have been built into the building codes over the years, and a huge part of what PTI and post-tension structures get. So
Yeah, it's a good point, Tim. And we've done a lot of work both at PTI and ACI and all the other codes trying to get that implemented. And I think we're at a good point now. Something I do recommend though, if you're a young engineer that you haven't done a lot of PT work and maybe you're doing some design or you're working under a mentor that has done a lot of design, is to look at the M10.3 field procedures manual and just kind of understand that before you go out on site and take a look at it. There's a lot of things in there that are very important. You know, we can design a great structure, but if it's not implemented, if it's not constructed, you know, the right way with people doing the right things, then it can not only affect the design, it can affect the durability significantly. So that's something that, you know, it's really meant for the people in the field, but I think as an engineer, as a designer, knowing more about it is a really good thing. So I would recommend. We're actually coming out with a new M10.3 here shortly. So that's something that I would recommend a young engineer take up and read on.
Tom, that's a very good point, and I also want to add that all the Post-Tensioning Institute is really doing a wonderful job of course, not only promoting post-tensioning, but providing the resources to engineers, to architects, contractors, young engineers who want to enter the field, you know, who are out of school. There is the PTI manual is a fantastic resource for any and everything about post-tensioning. And so is the new post-tensioning code, which is our first code in 2025. But there are chapters in the PT manual on parking structures, on durability, and there's a lot of resources on that engineers and contractors and owners can use about post-tensioning, about the durability of post-tension. So I highly recommend that these materials be used. They are available for the public. So
I want to piggyback off that because you know, I think both of you guys said this, but I want to draw attention that I think from a contractor standpoint, from whether you're a project manager, superintendent, or foreman, being familiar with these tools is an amazing asset. It sometimes in certain parts of the country, it kind of comes across that PT is a little bit of an enigma, but it's really not. And we've got the tools out there to help with some of these things. You've got the certifications that you can go through that Tim mentioned. But you know, starting the job right is key to building it right. And things happen on the job site, and those tools, whether it's the M10 document or the PT manual, are written very well that you don't have to be an engineer to understand what's written there. There's some tools in there to help with day-to-day operations. So I'd recommend it for anybody across the board.
I also want to add that one tremendous enhancement to the durability of post-tensioning structures is now the increased emphasis on tendon finishing, because that is the key to protecting the tendons long term, right? So now there is more 301, ACI 301 has more requirements on it. The PTI M10 specification that Tom talked about has a lot more information and emphasis on tendon finishing, which is basically approving the elongations in a timely fashion, cutting the tendon tails, installing the encapsulation cap, and then of course grouting the recess, the stressing pockets. So there's going to be and having inspectors inspect it too. So there's a lot more emphasis on it, and I think this push to on tendon finishing is going to improve greatly the durability of post-tension structures. And the same thing applies for unbonded tendons and for bonded tendons, where in the case of bonded tendons, it's the emphasis on grouting. So, and there is enough specifications that PTI has that cover all these items.
Yeah, I think that goes to what you said before, Asid. If we are finishing those tendons correctly, the water never gets there in the first place, right? Finish them timely to limit that ability.
Well, you know, I will say that a lot of times when we're presented with a project and the owner's looking for multiple systems, right? Different construction types. We look at upfront cost and then we look at maintenance cost, right? And a solution might look cheaper up front, but if you're gonna keep it to the end of life, you're gonna have to perform maintenance on it. And I don't think I'd say that some owners have really no interest in understanding the maintenance costs, and for a myriad of reasons. Others do. And when presented with that, it's highly contrasted between a post-tension structure and other structures because of the maintenance that's associated with it is much less demanding. You're really just keeping up joints and you're washing it down. I mean, those are the two big things. And when you have fewer joints, you have fewer things to maintain. You have less sealant to maintain and all that. And so, yeah, there's the cost side of it. And I think we've talked about that before. But from a terms of durability, when you're not having to perform all this maintenance and chasing cracks and looking at joints and all this, I mean, it's beneficial. That the outcome is beneficial, and typically you can end up with a longer life structure by doing a minimum amount of maintenance on most jobs. Most projects, I think, we're asking owners, you might want to wash it down once or twice a year. So it's some hose bibs and it's, getting a guy out there to do it. So yeah, absolutely. From that perspective, it pays dividends in the end. A little bit more upfront cost. You save a ton of maintenance cost.
Yeah, I can say that I've done several hundred garages over my career, and I get very few phone calls. So to me, that's a testament of the long-term durability. And I'm talking over a period of more than 35 years. So that tells me that it is a very durable product. And if done right, then you should see very few to minimal issues. And I want to add to that. I'm sure some of you can share your experience on your over the years. What have you seen on your projects? Where have you received phone calls, or have there been issues? But I seriously think that you would have probably of all the other garages you might have designed, you probably have got the least phone calls if it's a cast in place post-tension deck.
And I'd add to that, again, from the contractor seat, you have so much control. I think that's the piece that from day one, you've got, we talked about control and, how it's built and how you warp it and whatever, but you've also got control over the concrete you're using, finishing processes, sealers, things like that can help protect when you're not bringing in multiple pieces and putting them together, you're actually building it there. You've got more control that limit some of the things we've talked about that allow it to have that longer lifespan with limited impact.
We talked early on about the pre-compression and the ultimate goal of mitigating cracks, and obviously the environment that the parking structure is in is kind of a cross between a bridge and a building. You've got exposure to the elements, whether you're in Arizona or Buffalo, New York, it doesn't really matter. You've got different types of elements that you're exposed to. Maybe chat a little bit about one of our other publications, DC 20.2-22, which is a really useful document talking about mitigating restraint cracks. Obviously, any structure is going to go through volume changes over time. And, there's, initial shrinkage of the concrete, there's elastic shortening, creep, all those things happening. So it's a moving building. It's got a life of its own. But, PTI has put together a resource to help come up with strategies for detailing and things that have to do with, all things post-tension buildings, not to mention parking structures, and maybe just chat a little bit about that resource. And again, how it all is really tied to long-term durability. At the end of the day, those things are focused on durability, and used to be, it was a goal to get to like a 50-year service life. Then that's expanded to 75-year service life, and not too long from now it'll be a 100-year service life. And so, when you're trying to achieve those types of durations, And we've even talked in our previous discussion about sustainability. If you're not having to get rid of a building, quickly and rebuild a new one, you're also directly feeding the sustainability goals as well. So anyway, I'll let folks kind of chat about DC 20.2 if you'd like.
I think one of the things I would add is that we talk about building these structures in different parts of the world, and that it ties into the flexibility that I was talking about earlier, that you know we have control over to help with some of the initial shrinkage and things like that, how we cure these slabs. There's a lot of control. You can do that specific to the structure you're building. Structures act differently depending on how they're anchored or the weather that they're in. And so whether they're on the beach or they're not. So being able to have some flexibility with mixed designs, with curing methods, placement conditions, can eliminate some of the early cracking that may come from those things and help the durability long term. Again, going back to Asid's point earlier, if we eliminate those cracks from the beginning, Asid or David, whoever said it, then we increase the durability long term.
Another resource publication that's coming out, updated soon, from our DC 25 Parking Structures Committee, as an update to a very popular publication that's kind of been in place for a while that needs updating, but we've been working hard to add new content as well to it. And it's a DC, it's going to be called DC 25.1. It's our really the guide to cast in place post-tension parking structures, design, construction, maintenance, all things PT parking decks. And so it's another really valuable resource that's already in existence but being updated, and it will get into a lot of guidance on the right things. And there too, I mean, you're talking about, again, it's just really more to keep people organized and exactly how that can be accomplished with a post-tension parking deck. It's not as though it's this complex process to design a PT parking deck. They're quite simple, to be honest. Most often a one-way beam and slab system, multi-level parking structure. A lot of other times a two-way slab system, on a 30-foot grid for something, for example, or something standalone under a building, subterranean. And there's just sometimes a lot of misnomers out there about how you go about it and what it involves. And so there's all these different things that help you understand how to do that, not only correctly, but it's a fairly straightforward process. And again, the durability conversation focuses on doing it the right way. I mean, I almost want to say that you could almost inadvertently design something incorrectly in terms of worrying about all the durability things, and it would still be extremely durable because it's just the nature of post-tensioning. Post-tension concrete, pre-stressed concrete, is inherently durable, but it's really advantageous to even take that extra step to understand the resources that are available to do all the other detailing things and other strategies that help out. So that's another resource.
Okay, I was going to, so to add to the resources I was talking about earlier, PTI came up with it was an updated document in 2022. It's DC 20.2-22. It's on restrained cracks and their mitigation in unbonded PT building structures. And that is a document that was revised after many, many years, and it offers a lot of information about how to mitigate cracking in cast-in-place post-tension structures, which includes parking garages as well. Parking garages come in all different shapes and sizes, and you have, depending on the region of the country, you can have, like in California, where you have a lot of shear walls required in your parking structure, or if you move east, you can have moment frame systems. So regardless of the type of framing that you have in your parking structure, the restraint issues can be handled with details and different techniques. And which improve the performance of the structure. So I was mentioning earlier, you can have a 400-foot building or 500-foot building or 300-foot building, but using expansion joints at the right locations and using pore strips, you can still come up with a monolithic building that has the least amount of construction joints. So that resource offers different details for what to do at shear walls, how to mitigate cracking at stiff elements, release details, what to do at pore strips, and I think that's a tremendous resource for professionals.
No problem. It's basically a resource that provides methods that help eliminate the most common points of deterioration, which is cracking, and what causes that cracking. So whether it's, like you said, a seat, whether it's from restraint or shrinkage or whatever. Really, the point is that it's a resource that helps. The biggest problem from durability for any concrete structure is cracks, and there are several resources out there that help point out methods to mitigate those cracks.
No, absolutely. I actually refer to those spots as hot spots. So you can identify the hot spots typically as to regions where you can potentially get cracking due to restraint. And that document offers the different solutions by which you can accomplish that. And case in point, I mean, I've been using it for so many years, and I've really had very high degree of success by using the techniques to control cracking. So,
I think young engineers don't often think about volume change effects, because that's a code requirement, right? We have to deal with that. And I think some designers just ignore it altogether. And you can kind of get away with it maybe for interior buildings because it's not seeing the temperature swings and all that. But I will say, and we've said this before, PT's been around for decades, and I think there's maybe some hesitancy to some in the industry to think it's some wild animal that they can't tame. I mean, it's not that difficult, and there's a ton of resources that tell you how to do it. But what I have noticed is when I'm doing post-tension design, the effects of PT kind of magnify some of the concepts that you have to think about in design, because you're putting forces in the slab that you wouldn't normally be thinking about. And when it comes back to restraint, cracking, and things, when you think about how to implement a PT system, you really do have to think about how they're going to build this whole thing and how they're going to sequence it. And it really forces you to think about how a contractor might want to build something, and maybe how they almost need to in some places. And that has really kind of forced me to think very deeply about the construction method and things like restraint cracking, where might be a shear wall be, where might a hot spot be. And those things aren't maybe things I would have thought about, say, in other types of construction. And so the benefit that I also see in designing these types of structures with PT is that it really does cause me to think a little bit more critically about the design in general. And that's only better for the owner, the end user, all that. And so I say that to say that all this ties in, and we've got some good resources to review that. And I think part of that resource came out of a need to understand what these structures are doing.
To add to what he was saying, what I think what you're trying to say, David, is you have a lot of control on how you design your member, and you can see the fruits of your of the efforts you've put in. So if there are hot spots or certain areas where you want to do certain things, you can actually implement those, and you will see that you will see the benefits of that once the structure has been completed, and those are long-lasting benefits. So that is something which is really the benefit of post-tensioning. So,
All right, so I think I'm going to kind of bring us to a conclusion here. Great discussion about durability. Greatly appreciate again everyone here on the panel to talk about various different aspects and details of that. Again, this ties in perfectly with everything else we've had in our webinar series. Every one of these kind of pillars of importance all are equally tied into the major benefits of post-tension parking structures. Durability is extremely important for the life cycle cost side of things and overall owner experience having a PT parking structure. Not to mention the fact that as an end user is in the garage, they're not dealing with parking structure closures for repairs, and they're not dealing with other tripping hazards and things that might happen if there's concrete spalling or there's cracks happening and things like that. So hugely beneficial. Encourage those who haven't maybe seen all the other episodes to remember there is an episode again on cost effectiveness, major economic advantages. There's the functional benefits that are very numerous about PT parking structures, and then sustainability and resilience is another one as well. So all these episodes linked together. Grab yourself a cup of coffee and go watch each one of them. And this fourth one in the series was great as well. I appreciate again the panel and for everyone's time to talk more about PT parking structures. Thank you very much.
Thank you for joining us today. Be sure to visit our website at www.post-tensioning.org for more information and resources. Stay connected by following us on our social media channels to keep up with the latest updates and upcoming episodes. We look forward to seeing you next time.